Up till now, we've been talking about multiplying and dividing rational expressions, and that's relatively easy, right? We just multiply across the top and the bottom and then have to simplify, and with division, we are just finding the reciprocal of the second rational expression and then doing the same process again. Well, with addition and subtraction of rational expressions, it's a little bit more complicated. It doesn't matter if there's a common denominator, right? That's fairly easy, and let's look at some examples of that, right? If we have 3 over t plus 5 over t, same denominator, nothing changes there. We just combine the numerators and we leave the denominator the same, and that just gives us 8t. Don't add the denominators, don't multiply, it's not t squared or something like that, right? The denominator just stays the same. And even if it's a little bit more complex, let's say we have something like 3a squared plus 7 over a squared minus 2a minus 8 minus 7 plus 3a squared over a squared minus 2a minus 8, right? Denominator is the same. All we have to do is subtract these things, so we can rewrite this numerator, okay, all together as 3a squared plus 7 minus, and I like to use parentheses because I want to keep my signs consistent, all right, all over a squared minus 2a minus 8. And what we're going to notice here is if we do distributive property with the sign, which we have to do, okay, we're going to end up with 3a squared plus 7 minus 3a squared. Everything's going to cancel out, leaving us with 0 over this same denominator, but doesn't matter because anything divided by 0 is 0. And that's our answer. So my point is, with the same denominator, all you're doing is adding and subtracting the top, and it's just a matter of managing signs, making sure you're clear about which signs carry through, which ones don't. If you're adding, all the signs stay the same. If you're subtracting, just make sure that in that second rational expression, you do this distributive property thing, so that that sign goes to each term in that second rational expression. The trickier part is the second group of problems, and that's where you don't have a common denominator. And let's remind ourselves, so here's a traditional rational expression, right? Just 3 over x squared, very simple, and we're going to add that to 5 over x. The problem here is we don't have a common denominator. We have to make a common denominator. And the way we're going to do that is we're going to look at, okay, this denominator has x times x, this just has x. So how do we make them the same? Well, we multiply this rational expression by 1, but 1 in the form of x over x. So now we have 3 over x squared plus 5x over x squared. Now we have a common denominator. We can add these things together, 5x plus 3. They're not like terms, so there's no simplification. Denominator stays the same. Okay, and that's the kind of thing you're going to be doing in this next section. Okay, that's a very easy example, but that's the kind of idea. You're always going to be looking for what does this denominator have that this denominator doesn't have, and maybe both are missing something and you have to do multiplication in both cases. Let's look at an example like that. Here we have 6 over a squared plus a minus 2. We want to add that to 4 over a squared minus 4a plus 3. Okay, here the denominators are not the same, and it's not readily apparent how we're going to make them the same. So we have to factor these denominators first. So if we factor this first denominator, we're going to get 6 over 2 binomials, a plus 2 and a minus 1. Then let's do the same thing for the second denominator, and that's going to be a minus 3 and a minus 1. Now, I want to emphasize for you, it's important that you remember your factoring tricks here, okay? So if you don't remember how to do those factoring tricks, you really need to practice those and make sure that by now factoring is second nature to you, because all of these problems are going to involve it. Okay, we notice we have a plus 2 and a minus 1, a minus 3 and a minus 1. We have a minus 1 in both of them, but one of them is missing an a minus 3 and the other one's missing an a plus 2. So we have to include those. So this one needs an a plus 2. So we have to multiply by a plus 2 over a plus 2. Here we have to multiply by a minus 3 over a minus 3. So now we have 6a minus 18 over, and I'm not even going to do this multiplication. I'm just going to list out all the things that are there now. Don't worry about foiling it out, because there might be cancellation down the road, and that would cause us to factor again. And here, remember, this is distributive property. Consider this in parentheses, okay? We have 4a plus 8, and same list of binomials. Again, I'm not going to multiply them out. There's no reason to. I'm probably going to be able to cancel in the near future, so don't worry about multiplying out. Okay, now I'm going to add these things together. So 4a and 6a give me 10a. Negative 18 and positive 8 give me negative 10, all over a minus 3, a plus 2, a minus 1. Now, it might seem like we're done, but in fact, what you might notice about this numerator is it can be factored. We can factor a 10 out of there. So this is 10 times a minus 1 over a minus 3, a plus 2, a minus 1. Now we have an a minus 1 in the numerator and the denominator, which can cancel out, leaving us with a final answer of 10 over, and again, don't worry about doing the multiplication, just leave it in factored form. And that's our final answer. Okay, so there's a lot of steps to this, okay? Initially, you're going to end up with a problem like this, and you're going to say, okay, I don't see anything in common. But then remember, you have to factor it. You have to see what the binomials are so you know what to multiply by. And then once you do that, don't worry about foiling. Just leave it in its unfoiled, factored state. Combine the numerators, factor the numerator out to see if there's any cancellation available, and then write your simplified form. Okay, and it's just going to be iteration after iteration of that. So those are the major things you're working on over break. Adding and subtracting rational expressions. First with like denominators, and then not with like denominators, so that you have to make like denominators. If you have any questions, email me. I won't post this with any questions, so that if you want to rewatch it, it'll be nice and easy to rewatch. I suggest rewatching it. I suggest reading through your book a little bit over break and coming back with this knowledge well in hand. Remember, please, that you have a test when we get back on that Wednesday. All right?